Docker piece. Look at this list. 6 containers, 4 of them you don't even remember starting. This is what most developers call normal. Now look at this. Docker images. 1 repository, 1 tag, 1 gigabyte, and 40 megabytes for an app that renders a single JSON endpoint. Nobody flinches at this number anymore. That's the actual problem. Everyone online is telling you Docker is dead. Switch to Podman. Switch to container directly. Go rootless. Go Kubernetes native. And sure, some of that conversation is real. But here's the part nobody tells you. The tool isn't what's failing you. Your Docker file is. And it's been failing you since the day you copy-pasted it from a tutorial 3 years ago and never touched it again. Here's the actual problem. Most developers treat a Docker file like a virtual machine setup script. Install the language runtime, install the package manager, install every build tool needed to compile the app, copy the entire project directory, run the build, ship it, all of it. The compiler, the dev dependencies, the cache files, the Git history if you forgot your Docker ignore, all of it rides along into production every single time you deploy. That's not a Docker problem. That's a discipline problem wearing a Docker costume. So here's the object. Here's what actually fixes this. And it isn't a new tool. It's the multi-stage build, a feature that has existed in Docker for years and that most teams still aren't using correctly. And the impact number is not subtle. Real-world Node and Go applications routinely go from image sizes over 1 gigabyte down to under 100 megabytes. Not a rounding error. A 10 times reduction, sometimes more, using nothing except the same Docker engine you already have installed. Let's slow down and actually look at this, because the mechanics matter more than the headline number. A multi-stage build means your Docker file has more than one from instruction, and each one starts a fresh, isolated stage. The first stage, usually called the builder stage, is where all the heavy stuff happens. You install your compiler, your package manager, your dev dependencies, and you run your build command there. That stage can be as bloated as it wants. It never ships anywhere. The second stage, the runtime stage, starts from a clean, minimal base image. And instead of reinstalling everything, you use one instruction. Copy from builder. That line reaches into the first stage, grabs only the compiled output, the binary, the built assets, whatever your app actually needs to run, and drops it into the clean image. The compiler stays behind, the build cache stays behind, the dev dependencies stay behind, only the finished product crosses over. Here's the strange part. Most developers who've heard of multi-stage builds still get this wrong, because they don't pay attention to instruction order. Docker caches each layer of your build, and it invalidates that cache the moment anything above it changes. If your Docker file copies your entire source folder before installing dependencies, then every single code change, even a one-line fix, forces a full dependency reinstall on every build. Flip that order, copy your package file first, install dependencies, then copy your source code. Now your dependency layer stays cached across builds, and only the last layer rebuilds when your code changes. Then there's the base image choice, which is its own quiet disaster. A lot of teams build their runtime stage from the same full language image they used for building, a Node image that ships an entire Debian system, or a Python image carrying compilers nobody needs at runtime. Switching that runtime stage to something like Alpine or a distroless image strips out the operating system layer you were never using anyway. That single swap alone can cut tens of megabytes off an image before multi-stage even enters the picture. And then the file almost every developer forgets. .docker ignore. Without it, Docker happily copies your local node modules folder, your .git directory, your test fixtures, your log files, anything sitting in your project folder, straight into the build context. That's deadweight bloating your image and slowing every single build. Now let's talk numbers, because this channel doesn't do vibes. A typical Node.js API built the lazy way with a single stage and no cleanup lands around 1.1 gigabytes. Same app, rebuilt with multi-stage and an Alpine runtime, 70 to 90 megabytes. A Go application is even more dramatic, because Go compiles to a single static binary. Done right with a distroless runtime stage, that image can land under 20 megabytes, down from a build stage that might be over 800 megabytes with the full Go toolchain installed. Python sits in between. A poorly built image can hit 900 megabytes with compilers and dev headers included. A properly split multi-stage build with slim base images regularly lands under 150 megabytes. That size difference isn't cosmetic. Smaller images pull faster on every deploy, which matters directly during incident response when you need a rollback or a scale-out event to happen in seconds, not minutes. Smaller images mean lower storage and egress costs on your container registry, and at any real scale, hundreds of deploys a day across a team, that adds up to real infrastructure spend, not a vanity metric. One mid-sized engineering team reported cutting registry storage costs by more than 60% after standardizing every service on multi-stage builds, purely by removing build tooling that had been shipping to production for years without anyone questioning it. Now, let's be honest, because that's what this channel actually does. Docker gets a B here. Not an A and not a C, not an A, because Docker still carries daemon overhead that tools like Podman genuinely improve on if your team has already invested in rootless container workflows or needs tighter integration with a Kubernetes container runtime interface without a background daemon running at all. If you're already fully committed to that stack, or you're running serverless functions where the runtime abstracts the container away entirely, Docker plus multi-stage builds isn't solving a problem you actually have. Not a C, because the Docker is dead narrative is mostly recycled hype from people who never fixed their Docker file in the first place and are blaming the tool for their own habits. If your team is still building images the way tutorials taught in 2018, single stage, full base image, no Docker ignore, no layer ordering, you don't have a Docker problem. You have a 5-year-old bad habit problem, and swapping tools won't fix that. It'll just give you a new tool to build badly. So, to recap, most bloated images come from copying your entire build toolchain into production instead of only the finished output. Multi-stage builds separate the build stage from the runtime stage, and copy from builder carries over only what's actually needed. Layer ordering, dependencies before source code, keeps your cache working instead of fighting you. Minimal base images like Alpine or Distroless strip out operating system weight you were never using. And .docker ignore stops your build context from smuggling in files that were never supposed to leave your laptop. Put all 5 of those together, and you're looking at image sizes shrinking by 10 times or more, using tools you already have installed right now. So here's the actual debate, and I want a real answer in the comments, not a reflex. Are you actually running multi-stage builds in production today, or are you still shipping your entire build toolchain because it works and nobody's measured the image size in over a year? No hype, just the stack. See you in the next one.